In this video, we'll learn the phase relationship between current and voltage when AC circuit connected to the inductor. The symbol of inductor, this is AC voltage source. So this pure inductor connected to the AC circuit. At any instant, EMF of the AC is E is equal to E naught sine omega t. And this AC voltage passing through the solenoid or in the pure inductor, induced back EMF is produced. That induced back EMF in the inductor is L di by dt, which oppose the applied EMF. So here minus will come. This is induced EMF in the inductor, which oppose the applied EMF. So a negative sign. Net instantaneous EMF is equal to E minus L di by dt. Here E is in the positive, here plus will come. For negative sign, here automatically negative sign will come. But this EMF must be 0 because there is no resistance in the circuit. So E minus L di by dt is equal to 0. E is equal to L di by dt. Then EMF. So applied EMF is E naught sine omega t is equal to L di by dt. Then di will be on side. Then E naught by L will come to denominator, sine omega t. Then dt will go to numerator. So we need a current. So we have to integrate. So on integrating, integral di is nothing but I is equal to E naught by L sine omega t into dt. Then I is equal to E naught by L, constant value. Integral of sine omega t, we know that minus cos omega t. Then integral of this omega t divided by omega. So I is equal to minus E naught by omega L cos omega t. Then I is equal to minus I naught cos omega t. So from 4 quadrants, all silver teacup. From this trigonometric function concept, minus cos omega t is equal to sine omega t minus pi by 2, so that I is equal to I naught. Instead of minus cos omega t, we can substitute sine omega t minus pi by 2. This is current equation when AC source connected to a pure inductor. So from these two equation, EMF equation and this current equation, from these two equation, so here E is equal to E naught sine omega t. Here there is no minus pi by 2 and all, but here there is a minus pi by 2. So the current lagging behind the voltage by the phase angle of pi by 2, or voltage is leading the current by the phase angle of pi by 2. So here current, voltage and current, they are having the phase difference. Phase difference generally is pi by 2. So that phase difference, which one is leading? Voltage is leading and current is lagging by the phase angle of pi by 2. We will see the maximum current I naught is equal to, if you compare these two equation, I naught is equal to E naught by omega L. This is peak value of AC. Peak value of AC is omega L, also known as inductive reactance. Inductive reactance denoted as XL is equal to omega L. is equal to E naught by omega L. This is maximum current in the inductor circuit connected to AC. We can show the phase difference in the graph. This sine wave function represents for AC voltage, so E naught sine omega t is a graph plotted E versus omega t. Then in the same graph we can plot the curve for current, so that current lagging behind, because voltage formula E is equal to E naught sine omega t and current formula E is equal to I naught sine omega t minus pi by 2. So here current is lagging, so pi by 2 is lagging. So pi by 2 lagging means it should start from at pi by 2. So 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. So the current should start from this pi by 2. So that this blue line represents I naught sine omega t. So from this graph we can understand here at pi by 2 voltage is maximum but current is 0. At pi current is maximum but voltage is 0. Anyway, at first maximum for voltage at pi by 2, first maximum for current at pi. So the phase difference between current and voltage is pi by 2. Then we can show the phasor diagram by using the rotating vector. At any instant, that is t1 instant, omega t1, now draw a parallel lines. This line represents for current, this line represents for voltage. Now draw line, diagonal line from this origin. This represents E naught sine omega t1. This round represents, below one represents I naught sine omega t1. Here the angle between E naught and I naught is pi by 2. So current is leading, voltage is leading, current is lagging. When you rotate in the anti-clockwise direction, so the voltage is leading the current by the phase angle of pi by 2. Extend this line to find the maximum voltage and maximum current. Extend this line also. So this projection represents maximum voltage E naught. This projection represents maximum current I naught. So there is a phase difference between current and voltage by the phase angle of pi by 2. Power supplied to an inductor over one complete cycle. First we will discuss that instantaneous power. Instantaneous power P is equal to Vi at any instant. An inductor connected to AC, the voltage formula V is equal to V naught sine omega t, then I is equal to I naught sine omega t minus pi by 2, because current is lagging behind the voltage. Substitute this V and I in this equation. For instantaneous power, P is equal to V value V naught sine omega t and I equation I naught sine omega t minus pi by 2. So P is equal to V naught sine omega t into I naught. We know that sine omega t minus pi by 2 is nothing but minus cos omega t. Then P is equal to minus, we can take front V naught, then I naught also take front, then sine omega t into cos omega t. For our convenient or to use the trigonometry identities, multiply with 2 by 2. This is like 2 sin A cos A. So 2 sin A cos A, 2 sin A cos A is equal to sin 2A. So we are going to use this sine 2 omega t. Now average value of power over a complete cycle. So average power bar over the P represents average power, bracket represents average value of the quantity P naught I naught by 2 sine 2 omega t. Now average power is equal to is minus P naught I naught by 2. You can take out the constant values. Average value of sine 2 omega t. This average value of sine 2 omega t is 0. Hence the average power over a complete cycle is 0 when inductor only connected to the AC voltage source. So there is no power dissipation in this circuit.